Okay, so we're going to continue looking at sections 5.3 and 5.4, but our focus right now is going to be on a very important idea called reference angles. This is something that allows us to kind of connect what we did with the right triangles and the acute angles in a right triangle with trying to find the trig functions for any size angle, okay? All right, so a reference angle, we call that theta prime of an angle theta, is this acute angle that you make by taking the terminal side of your angle and dropping a perpendicular to the x-axis. And you always find these relative to the x-axis. That's very important. And you should be drawing pictures when you do these. You should be thinking about pictures when you do these. So let's go ahead and take a look at how to find the reference angle for each of these, okay? So for theta equaling 210, you should first think about where that's located. All right, so you know you're going to go all the way around here. That's 180, and you're going to think about going past 180. It's 30 degrees past 180, so it'd be like right there would be 210 degrees, okay? So that angle is 210 degrees. That's the theta that they're talking about, okay? When you think about theta prime, you should be thinking this, making a little triangle relative to the x-axis, and theta would be that angle right there between the negative x-axis and the terminal side, just that little extra piece past the 180. So that would be the 30 degrees, it turns out. Now, you shouldn't just memorize like what to subtract or to do. You should picture it to decide what to do, because there's a lot of variability about where these angles wind up being, and you need to be able to look at it to see how to determine your theta prime. So that would be theta prime right there, okay? So theta prime would be 30 degrees when theta is 210. That would be your reference angle, okay? All right, so let's look at 7 pi over 4. So first you think about where that is. Don't change it to degrees. Learn to count. Since the denominator is a 4, imagine breaking up 180. So this would be 180, breaking it up into 4 chunks, and then just count your way around, and you might have to keep going. So you might want to go ahead and draw those in there. So this would be 1 pi over 4, that's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So if I go, let me draw it in red. So if I go like all the way around to here and make that the terminal side, that would be 7 pi over 4, okay? Now what sometimes helps on these, like, you know, you started here at 0 radians, 1 full revolution is 2 pi radians. And then thinking about 2 pi, but thinking about it with a denominator of 4, can you see how 2 pi would be the same as 8 pi over 4? I use that a lot when I'm trying to figure out my theta prime, because this is theta, this all the way around, you know, the 7 pi over 4, that's your theta, okay? Theta prime is just this little angle right here. Just how big is that amount of rotation? And you see how you're 1 pi over 4 away from hitting the positive x-axis again? Theta prime is pi over 4, because you're pi over 4 away from there. That's the missing piece, okay? All right, let's look at negative 240. I'll bring this guy, this was supposed to be 3.6. I must have cut it off. I'll bring that down to the next line. Okay, let's do negative 240. So negative 240, let's think about that. The negative means you're going to go in a clockwise rotation. So you're going to go around this way. Okay, that would be 180, and you have to go past 180. Okay, and let's see. So that's 180. So I'm just looking at the 180 and the 240, not the, I'm just doing this right here. And I can see that would be 60. So I have to go 60 past that, and that would be negative 240 degrees, okay? All right, so that's my theta. All right, when I do a reference angle, I'm gonna imagine dropping the perpendicular here, this is theta prime, okay? That angle right there inside that triangle is your theta prime, okay? And so that means I really just want to know what that amount of rotation was between the 180 or the pi and getting to here. You see that? I just need that little piece from the pi, 180 till 240. And wasn't that 60? Theta prime equals 60, not negative 60, just 60. Okay, it's always just a positive acute angle. Okay, we'll do this one after I get finished with the others. I'll squeeze it in. Okay, all right, let's look at another one. Let's look at E. All right, now this one rotates around. One whole time would be 360. Then I'd have 305 more degrees to go. So I have to go, that would be 180. Okay, that would be another 90. That would be 270. So let's see what happens when I take 270 away from that. Okay, so I went around one whole time, and that's 360. And then that left me with 305 more degrees to go. And so that would be 180. That would be 270. So that would get me to 35 degrees past it. So that means I have to go a little ways past it. And that would be the 665 right there. Okay. All right. So this one's just a little bit tricky, I think. So the angle we're talking about for the reference angle is this one right here, just this between the positive x-axis and the terminal side. Just that angle right there is our theta prime. Okay, so it would help for you to remember that we went 35 degrees past 270 because I need the complement of that. I need the remaining amount I would need to get to the 360. So I was thinking about it as 90 minus 35. That would give me 55 degrees. So theta prime should be 55 degrees. That's this angle right here, okay? You also could say 305. Remember how we could take off one whole rotation? This angle right here is coterminal with a 305 degree angle. And you see how 305 degrees, this is another way you might think about it, is 55 degrees away from 360, which would be right here. So that's another way to get it, okay? All right, let's try another one that rotates around quite a bit. All right, so this one has a denominator of 4 again. So that means when you're thinking about it, you might want to cut your 180 into 4 pieces so you can do the proper counting. And also remember that this is 2 pi radians. So that would be the same as 8 pi over 4. And see, if you went around a whole nother time, wouldn't that be 16 pi over 4? Okay, if you added 8 pi over 4 to that, so you went around a whole nother time, you'd be back to here, and that would be 16 pi over 4. So that's going to kind of be what it's going to help us. So if we counted around, we'd be 1, 2, 3, 4 pi over 4, 5, 6, 7, 8 pi over 4. If we went around a whole 8 pi over 4, that would be 9, 10. Let me do it again, okay? Let me do it again. I lost count. So here we are at 8 pi over 4. That would be 9, 10, 11, 12 pi over 4, 13, 14, 15 pi over 4. So you might count around until you get to that 15 pi over 4. Or when you get to be a little more flexible with how you're thinking, this is what helps me. I'm 1 short of going around again. And the reference angle is actually going to be this angle right here, which is 1 pi over 4. Okay, so theta prime equals pi over 4. Okay, all right, now here's another one that had a 4, had a negative. Okay, so I'm going to go around still thinking about it broken into fourths. So this would be negative 4 pi over 4. This would be negative 8 pi over 4, negative 9, 10, 11. It would be right here. Okay, and so my reference angle I'm needing to find is this guy right here. And once again, we're back to the reference angle needing to be just the pi over 4. You're always looking at the terminal side, and the x-axis is what makes your reference angle each time, okay? All right, now there was one up here that's a little tricky to think about because it doesn't have degrees on it and it doesn't have a pi in it. It's that 3.6. So let me move this out of the way. Just put it up a little higher. So this one had a theta prime equal to 60 degrees. Let me shorten this just a little bit. Okay, let me draw this little short one. And then let's do D right here. So D had theta equaling 3.6. And I think that's hard sometimes to think about because you don't have a pi on it. But remember how pi is about 3.14 and how this is pi? Well, so that's about 3.14. So 3.6 should be around here, and then it should be past that some, okay? And then the reference angle we're looking for is this angle right here, which is how far past pi. That's what you're looking for, is how far past pi did you go? So just go up here and subtract 3.14. And so that would be 0.46. So theta prime should equal 0.46. And this was radian since it didn't have a degree symbol on it. It's just a little awkward to deal with because you're used to all your radian angle measures having a pi in them, okay, but they don't normally. All right, so reference angles together with what the sign of your various trig functions are in each quadrant are what you use to do problems like this, determining the exact value of each of these and, without a calculator. And you got to learn to do this because you're going to have to explain it to me